Let me introduce the components of our 233 liquid-cooled energy storage cabinet. As you can see, here are our battery modules, pack modules, 5 in total. Then here are the MSDs that will be installed. After receiving the goods, we need to open this slot and insert the MSDs. Next, you'll see our battery high-voltage box. Its main function is to protect the batteries and provide power to the EMS. Here's a DC power supply switch. Then here is a DC circuit breaker, and then there's an AC power supply switch. Okay, next we see the PCS, which is the inverter. This device is mainly responsible for converting and outputting DC power from the battery. It mainly has an AC side circuit breaker and a DC side circuit breaker. Next is our 233 energy storage cabinet's liquid cooling system. This liquid cooling system includes these liquid cooling pipes that lead to the inside of the battery. Then there's a liquid chiller. This is the power cord for the liquid chiller. This is the communication line between the liquid chiller and the EMS control panel. This is the control interface for the liquid chiller's external control panel. And this is the liquid chiller's filling port. The liquid chiller uses drain and filling ports here. Through these two liquid cooling pipes, it precisely heats or cools the battery through active thermal management. Then it undergoes a thermal circulation process here, before entering our liquid chiller. Next, I'll introduce the power distribution cabinet of our cabinet. Its main function is to supply auxiliary power to our cabinet. This is a connection port for the AC power line. Then this is the auxiliary power switch, and this is the circuit breaker. Next, I'll introduce our EMS module, 4G module, and dehumidifier. This is our dehumidifier. We use the dehumidifier to ensure suitable humidity inside the cabinet. This is our 4G module. The 4G module provides external network access for the EMS. We can then configure it using a 4G SIM card or a wired network connection. Next, we'll introduce the communication and control logic of the entire cabinet. We primarily control the entire system through the EMS. Through communication commands, we can control the on/off state of the high-voltage box, set protection parameters, and control various settings of the PCS. For example, setting the output power of the PCS, and controlling the liquid chiller to achieve the desired cooling effect and power. The EMS controls the liquid chiller and the output and input of the power distribution cabinet through this communication line. Our pack also contains a BMU control system, which collects the temperature and voltage of the battery cells and sends this data to the BCU via this communication line. The EMS can monitor the battery status, and the PCS is controlled by the EMS through these two COM ports. Our cabinet's overall circuitry is as follows. 5 battery packs are connected in series to supply power to the high-voltage box. The high-voltage box provides 24V power to the unit and protects the battery power supply. Then, through 2 communication lines, the current is transmitted to the PCS. The PCS converts DC to AC, and then to the distribution box. From there, the AC input/output can be connected via our AC connection ports. External wiring connects directly to the cabinet through this port. The main wiring includes 4 power cables, a communication line for the meter, and other external communication lines, all connected via terminal blocks here. This is our fire protection system, primarily for connecting fire hydrants. These 2 ports are for grounding, specifically the ground wire. There's a small fan here to cool the small transformer inside the distribution box. These are ventilation holes. The vents at the back of the cabinet are all removable and washable. If dust accumulates inside over the years, they can be removed to prevent overheating issues.